Oh, I better plug my laptop in before it goes. Okay. 6 now. So you have this diagram here. The battery is 12 volts, internal resistor, or if the lights on the car have a total combined resistance 1.2 and the car engine is not running. Okay. Explain why the reading on the voltmeter connected across the battery would fall when the lights are switched on. Okay, so we'll just draw this here. We have battery, we have resistor, we have a big resistor here compared to that, and then we have a switch. Okay, and what they've done is they've put a voltmeter around the battery. Now, this we just need to be careful about here, okay? If the switch is open, the voltmeter tells me what? V equals 12. Because that's the voltage of the battery. Right? Well, actually, I should really put it around like this because the battery is actually here. Okay. So what would the voltmeter read? It would read as 12. And in fact, I think we did a question in class where we had to know that or use that. So when the switch is open, the voltmeter is just on the battery and the voltage is 12. Okay? But when we close the switch, so if I draw the current, here's the current, right now it's just going around like this. But when I close the switch, what happens is it goes around like this.
Doesn't this still come to voltage?
Not really.
Energy required to all come from 120 volts.
Yes, you've basically increased the resistance. But also, I also said this before as well. Here is like the A, and here is like the, no, sorry. Here is like the, hang on, it's going around this way. Yeah, sorry, this one's like the A, and this one's like the B. Because, well, I'll just get straight to the point. What I'm trying to point out is if I put the voltmeter around the battery, it's actually going to be the same deal as putting the voltmeter around here and here. And the reason I'm saying that, if you just think about it, is there anything on the circuit here? Is there any resistors here? No resistors, right? So, should this V change if I take this and move it to here? No. And is there anything here? No. So should it change if I take B and clip it here instead? No. So the point I'm making here is, for me, it is easier to picture the voltmeter around the resistor rather than around the battery. It gives the same number, but in my head, it makes more sense that you're measuring the voltage through the resistor, so I should put the voltmeter around the resistor. But of course, there's no difference. All you're doing is you're clipping this here to here, and you're clipping this here to here. And because there's nothing there, no change. Are we okay with that? Yes? So you said it, Tanish. The reason the voltage drops is because the resistance has increased. More power consumption and all that. So we'll just put that down. The resistance in the circuit increased. Or another way you can actually say it, maybe a little bit more accurate, is that in the first case when the switch is open, the voltage is 12 volts because it's on the battery. But in the second case, when it's closed, the voltage is giving you what it is through the 1.2 ohm resistor. So they're actually measuring different things, but it's going to be less than 12. I mean, it'd be silly if it was more than 12, because if it was more than 12, it meant that the resistor was providing voltage to the circuit, right? So, I mean, it can't be more than 12. It has to be less than 12.
Can we use like example of Ohm's law, like V equals to I?
I think that might be,
Like as the resistor.
yeah, I think you might risk getting things a bit muddled up. I mean, you can if you want, but for me, I would just leave it at that. It's only one mark. It's only one mark, so don't go too far.
If they were asked to explain it.
Well, you could say, you could mention Ohm's law, that voltage is current by resistance.
So current is voltage.
So by increasing the resistance, you've increased the voltage consumed.
Yeah.
So the voltage left is less than 12. In other words, it was 12 volts, nothing was consumed. You add a resistor, the resistor consumes IR voltage, so reducing the 12 down by IR amount. Okay, I've spent way too much time talking about a 1 mark question. Can I go on to the next part now? Yep. So B part is calculation. If the reading falls from 12 to 11 when the lights are switched on, calculate the internal resistance. So what they're saying here now is this is 11 volts through here. Okay, so we can use Ohm's law. What does Ohm's law say? V equals I or. So we have 11 over 1.2 equals I. So I got I is 9.17 amps. What's wrong, Hamish? No? Okay. That's not finished because what do I want? Internal resistance. Okay. I would like to use Kirchhoff. Would anybody object? Of course not. He's not seriously objecting, are you? So Kirchhoff here would say, I'll write down here, you have 12 minus IR minus IR, yeah, again, equals, oh yeah, I'm going to put the numbers in a moment, yeah, equals 0. So we have 12 minus 9.17 or minus I or, which is the V, which is 11. That equals 0. Wasn't the 11 given in the question? Yeah.
It's much easier to use Kirchhoff.
I like Kirchhoff. He makes me happy. Alright, so here I got or equals, now I have a sign, no I don't have the sign wrong, 0.109 ohms. I'm trying to get you to love Kirchhoff. Feel the love. You know, I feel like we still don't like Kirchhoff. Hamish, I think I'm starting to convert you. You like Kirchhoff now?
Yeah.
Yes. Daniel? Ira, I still have to work on you. Do you like for Kirchhoff? So we have the internal resistance, B. I think I'm starting to convince Dana. She looks happy with this.
But what if I don't want to use Kirchhoff?
No, don't. Let's not go there. I really don't want to consider that. I really like Kirchhoff. Yes. Okay. Last part now, C. Explain briefly why 8 batteries of 1.5 volts connected in series to give 12 volts would not do the job here. So what you have, here they're saying you have a big 12 volt battery, and then they say, okay, why don't you take 8, 1, 2, 3, 4, 5, 6, 7, 8. this is 8 times 1.5 volts. So, is the voltage the same? Yeah, but this wouldn't work. Right.
It's because there's a lot of internal resistance in the battery, within the battery.
That's true too. You're absolutely right that there would be quite a lot of internal resistance. In fact, if this was one battery with internal resistance OR, and each of these had internal resistance OR, then there'd be an 8 OR.
Yeah.
So the battery would lose some energy. But I don't think that's quite what they're looking for, though. Anything else?
Yeah, in series.
Well, it needs to be in series to make 12 volts, because if they were parallel, it would total 1.5 volts. Anything else? Yeah. Well, basically it comes down to this. What's the formula for power? IV. And although the V's are the same in both, the power of these 8 will be smaller than this one big battery. Huh? Because the current is smaller. In other words, a small AA battery cannot release as many coulombs per second as a big car battery. The 8 small batteries provide less power than one big car battery of the same voltage, because it can release less coulombs per second than the big battery. In other words, it cannot provide enough power to start the car. Although it has the right voltage, it does not have enough current, therefore not enough power. So that's the answer. So you could say, although the 8 AA 1.5 volt cells provide 12 volts, the current is less. Therefore, the power is less. So for example, maybe the big battery can do 60 watts, but the 8 small batteries maybe only 6 watts. In fact, I don't even think it's 6 watts. Let me think. I would say a small AA battery I think would only really be 1 watt. So if you had 8 small batteries, what would that be? Just about 8 watts. Whereas I think a car battery, if you think about it, what does the car battery do? It can light the lights at the front of the car, yes? And what type of power would lights be? It'd be like 50, 60, 70, 80, 90 watts, wouldn't it? Yeah, I don't know what car lights are. I think a car light would be more than that. So let's say 100 watts. So you see, at 100 watts, so the battery, I think, will be power provider of 100 watts, whereas 8 little batteries would only be 8 watts. So I really think the current is probably 10 times smaller in the AA batteries than in the big car battery. And that's it. Do you have what they say there?
The total internal resistance too large, so the current supply cannot be large enough to turn the electricity.
Oh, good. They combined both our answers. So I said the current would not be large enough, so the power would not be enough. And yes, because a lot is lost through internal resistance. Good. Good. And how many marks was that? 1. No, the last part. I feel a bit cheated. Okay, 1 mark.